Welcome to Intelligence Gathering. We are now going to look at Units 3 and Units 4. So Unit 3 deals with intrusion analysis, and Unit 4 deals with the zero trust model. So let's begin. In terms of intrusion analysis, we first of all want to understand what it is. And it is whenever our network has been compromised by some external sources. So the thing that we need to bear in mind is that we will have our digital assets, which are accessible over the network. And we want to ensure that these assets are kept safe. However, there are going to be persons on the outside who will want to be able to get access to these assets. And they will try and compromise the network by infiltrating the network. So what we want to have a look at in this session is how do we prepare ourselves against such an eventuality? And what can we do to ensure that the organization is kept safe? First thing we want to look at is what are the sources that we can analyze to determine whether or not an intrusion has taken place. And there are several possibilities here, starting with the log files. So operating systems typically come with log files. And the purpose of the log file is to indicate or to track what has happened, the kind of activity that has taken place on these devices. In Windows, we can use the event viewer and access the log files once we have administrative privileges. And in Linux, we can go to the var log directory, and inside that directory, we will find some log files that we can analyze. So the question now becomes, what are some of the things that we are looking for? Well, in terms of the log files, we probably want to look at the user accounts, see if there are any new users that should not be around, which means that someone would have compromised the network and would have added a new user, especially with administrative privileges. So that's something that we need to look at. In addition, we can also look at the activities of each user, because even users who are valid may be doing things which are illegal on the network. So they are going into places or spaces that they should not be going into. And by looking at the user logs, we can have an idea of the kind of activities which are taking place. So logs are an important source in terms of identifying what is happening on the network. We can also look at network traffic. Now, there's a lot of traffic that will be traversing the network. There are a lot of ports that are going to be open to allow applications to communicate. For example, and now I'm just talking quickly about system and application configurations. So we might have applications which are HTTP aware. And what that means is that they are going to be communicating primarily over port 80. So one of the things we want to do is to ensure that it is only these applications which are getting the traffic from port 80. Another thing that we want to do is to shut down ports which are not being used. So by default, we would want ports to be closed and they are opened only on the basis that they are actually going to be used. So that's something that we'd want to do. But by looking at the user account, we can see who has logged in and what they are able to do or what they are currently doing. We can also look at memory dumps, and a memory dump is when we take the contents of RAM and we dump it into the file so that it can be examined. And one of the things that this does, it will allow us to have an idea of which applications were currently running at the time and what data was currently being accessed. And this can give us an indication of what is happening. Also, in terms of system images, we can take snapshots of our system, and this can tell us when something has changed. For example, a new program has probably been installed, should not have been there. And the presence of this new application is now creating havoc. So that is when we realize that things are going wrong. So we can have a look at these sources in terms of trying to analyze what is happening within the system, which leads us to the kind of frameworks that we have at our disposal so that we can do a proper analysis. And the key thing to bear in mind here is that we often have to think like how the attackers think. So we have to put ourselves in their shoes so we can understand things from their perspective. And based on that, we're then better able to protect ourselves. Whenever an intrusion has occurred, then there are a set of steps that we want to follow. We want to identify the scope. We want to look at the evidence. We want to determine the cause, the root cause. We want to see what kind of impact the intrusion has. Then we want to develop a plan so that we can be better prepared for these eventualities in the future. And obviously, we want to communicate the findings so that the organization is aware of what has transpired, and also the organization is aware of the steps that I've put in place to ensure that we are better protected in the future. Now, having said all of that, let's quickly have a look at the models or the frameworks which are proposed. So we have the intrusion kill chain model, and it identifies a set of steps which the attacker typically uses to gain access and to infiltrate the organization. And by understanding it from their perspective, we're better able to safeguard ourselves against these attacks. So there's reconnaissance, where they identify their target and they do some research on the target. So they are not coming into the organization blind. They are doing their due diligence. They are doing their research. Then there's the weaponization, where they are now looking at how are they going to take advantage of the kind of loopholes that they are seeing within the system. And then there has to be delivery, whereby this is the channel that the attack is going to be launched over. Then once the attack has been delivered and it has been successful, then it means that the system will now be exploited. So we are now gaining access into the system, and we are now accessing stuff that we should not be accessing. Then they might do some sort of installation, because usually what they want is to have a long-term impact on the system. So this is where it talks about installing backdoors so that they can have persistent access. Then there's the command and control, because once they're inside, what they want to do is to take control of the system. And then they will do whatever it is that they had planned to do, whether it's a ransomware, meaning they want to extract funds or monies from the organization, or it might just be to disrupt the entire operation of the organization. So they might want to delete critical files or stuff like that. Now, once we understand how these persons think, then we can now determine what our mitigation strategies are going to be. For example, we understand that they are conducting reconnaissance. So it therefore means that what we can do is to ensure that whenever we are doing anything, we put in the necessary safeguards so that whatever we are doing is not easily observed, for example. You know, I've given this example before of you're going into places like bank and you're seeing people entering secure places and they're entering PIN codes. And just by observation, you can have a pretty good idea of which numbers were pressed. And in so doing, you are giving away vital information on how your system can be accessed. So it therefore means that we would actually though change out that kind of system. Maybe we'll just use a swipe card instead of using that PIN code so that the person who is observing has a more difficult time in terms of gaining access to the system. So that's the way that we need to think as security professionals. Another model is the diamond model, and you'll realize that there are some similarities between all of these models in terms of identifying the person who is doing the attack, understanding the kind of vehicles that they are using, the tools that they are using, etc. So the diamond model has four pieces to it. There's the adversary or the attacker who is going to make use of some infrastructure or some channel whereby or vehicle whereby they are going to deploy some sort of tool or technique that will exploit the victim. So that's it in a nutshell. So if it is that the attacker wants to shut down the operation of the organization, then they might be attacking a server, will be the channel. And the kind of tool or technique that they are using might be a DOS, a denial of service attack, in order to overload the server so that it cannot handle the valid requests. And in so doing, the victim is now unable to carry out the kind of operations that they should be carrying out on a daily basis because the server is overloaded and it is now inoperable. Another well-known model is the meter attack model. And if we have a look here at what it lays out, once again, this is from the perspective of the attacker. There's the initial access, which of course would have been done based on doing some background work, reconnaissance. There's the execution. There's persistence. Spoke about this over here, where we want long-term residency in terms of the system. Then there's privilege escalation. So we might have gotten in with lower credentials, but once we are there, we now want to beef up the credentials so that we can do more and more things within the system. So privilege escalation is a big thing in terms of going into networks and gaining access. Then there's defense evasion. So once you are there, then you want to see how best you can hide within the system so that you are not easily detected. Then there's the lateral movement, which also ties in nicely to privilege escalation. So you might be in one sector of the network. Let's say you have clerk privileges. Then you might want to now move up to supervisor privilege. And by doing that, you're now able to access other parts of the systems or have enhanced capabilities within the system. So please remember that you are using these frameworks as a tool by which you are going to analyze what has happened within the network with the aim of beefing up the security or ensuring this kind of safeguards which are necessary. Ensure that the organization, the network, and its assets are kept safe. Which now takes us to the zero trust model. And the zero trust model is the principle that says we're always going to assume that a breach has occurred. We're always going to ensure that we explicitly verify every person, every application that tries to do an operation within the network. And also we want to ensure that everybody, every application has the least privilege that they need possible. So if all they need to do is to read one file, we ensure that all they can do is to read one file. If the application needs to access web traffic only, then we ensure that only port 80 alone is open, nothing else. And that's why we had said earlier that by default, the security principle says turn off all the ports first. That is the default state. And whatever you want to open, you open only those things. All right, so that's the kind of approach that the zero trust model is bringing. Now, in terms of the architecture, we have the architecture right here. So we have the users. They want to use some sort of system. Notice it says here it's untrusted. But in terms of getting access to the enterprise resource, then there's some policy enforcement point that you have to navigate. And the policy enforcement point has two key things here: the policy engine and the policy administrator. And for ease of reference, we want you to think about authentication and authorization. So the policy engine, we can refer to that as being the authentication piece, where it's trying to determine who you are and are you equipped or authorized to gain access. And then the authorization part now deals with what are you able to do. So once we have verified that you are who you say you are, then we now ask ourselves, what are you supposed to be doing? And we grant access to those things. Now, for all of this to work, though, there are several things here that have been mentioned. For example, the CDM system, which is the continuous diagnostics and mitigation system, that has to be up and running. And what it simply means is that there's constant monitoring of the system to see what is happening, so that we can take the requisite steps that we need to take to ensure that the system is kept safe. We spoke about activity logs earlier and what the purpose are in terms of providing this kind of trail so that we can clearly see what is happening in the system and know who is there and what they're actually doing so that we can take the appropriate steps. Then there's going to be industry compliance. We're talking about policies. And if policies are going to be implemented, then policies have to be informed by something. Industry compliance is one of the places where we get the kind of information that we need or the rules that we need so that we can enforce them. For example, GDPR, which is a global standard, talks about how data is to be kept safe. And right here in Jamaica, we have now launched our Data Privacy Act, and that is also going to determine some of the rules and regulations that we are operating under. And these policies now have to be baked, or these rules now have to be baked into the policy enforcement point. Then there's also threat intelligence. We just looked at the models a while ago. And the thing to take from this is that there are certain actors out there who have a particular way of operating. And once we have an understanding of the kind of attacks that have been leveraged against the network, against the organization, then we can now have a better idea of how we are going to protect ourselves from a policy standpoint based on our understanding of the key actors who have been preying on the organization or who have been trying to get into the organization from a historical perspective. We also have the PKI, which is the public key infrastructure. And as you know from your security principles, this is where we have two keys, one of them being the public key and one of them being the private key. And the purpose of the public key is so that persons can encrypt stuff that they are sending to us. And then we will use our private key to decrypt these messages. So the public key is what we share with others so that they can do the encryption. And the private key is what we keep secret so that we can determine what kind of information has been sent to us. We can decode it in a secure way. Also, just to note that the whole concept of digital certificates as well and digital signatures are also governed by this public key infrastructure. So we already know that we want to ensure that everything that is happening in the network is always verified in terms of operations which are to be taking place. We also know that we always assuming that there's a breach. And we also know that each person is given only the kind of access that they need. So it's the least privileged access. We know that. But how do we now bake all of this in terms of the implementation? So we have some information here that can guide us. First of all, we define the attack surface. So what are we protecting? We ensure that we have our controls up and running that constantly monitors the network traffic. Then we create our zero trust policy. This is going to be based on the industry standard. We would ensure that the network has been architected so that all of this can be secured. And then obviously we have to monitor the network just to ensure that things are running as intended. And if there are any breaches, then we ensure that we activate the mitigation policies so that we can get back to the sort of trust level that we want to have. And just to quickly talk about the whole concept of microsegmentation, because this is an important concept when it comes to protecting the network. What we want to do is to divide the network into smaller units, usually logical units. And we want to ensure that the kind of policies that govern these different segments are up and running. And there might be slightly different policies based on the different network segments. So that's something that we need to bear in mind. Now, what microsegmentation does is that it isolates these network components. And by so doing, it reduces the amount of lateral movement that can occur in case there is a breach. So in other words, it's going to kind of restrict like privilege escalation and so on, because we ensure that the segments are isolated to make it more difficult for persons to move from one network segment to another. And we can't end the segment without talking about cloud computing, because a lot of organizations now have part of their presence within the cloud. And because this presence is in the cloud, then there are some concerns that we have to navigate. But there are also some benefits that we can accrue. For example, reduced operational cost and complexity. So because it is in the cloud and most of the cloud services operate on a as you use it basis, then what it means is that if you no longer need certain elements, you can shut it down. If they, and in so doing reduce cost. You can also scale down. For example, you might realize that you have certain amount of traffic during certain seasons. So let's say you're selling goods, for example, then during the Christmas season, you might have more traffic than in February, for example. And so what you do is as you come to November, you would increase your bandwidth, you would increase your RAM and so on. But in February, then you decrease. And what this does is that it allows you to better control the amount of money that you have using on these services. And we can easily contrast this to having a localized presence where you have to build the servers for yourself. You have to get security personnel in-house to do the necessary security routines and so on. So this would be a long-term cost that you'd have to bear for the duration of the organization. Another thing about the cloud is that you are more agile and you're able to do things quicker. I will just talk about scaling up and scaling down. This is pretty simple in terms of the cloud, because you can easily launch virtual machines or tear them down at will. You also tend to have a better kind of security because you have a dedicated team of professionals who are working to keep these data centers secure. And in terms of visibility into your data, your assets, and so on, because all of these things tends to be centralized, then it means that you tend to have a better idea of what kind of data you have, what kind of policies are implemented to protect the data, and so on. This is made that much harder if your data is dispersed over different physical servers that you have under your control. Because in the virtual space, would have your containers, where it's easy to see what you have access to and what you should protect. And that takes us to the end of Unit 3 and 4. And the next unit that will be coming up is going to be Unit 5, which is our final unit. Take care.